Okay, so here's a video about 4.7. These are optimization problems. So there's not too much new calculus-wise in this section. It's just a lot of word problems involving maximums and minimums and what is the largest and what is the smallest. So the hardest part about these is setting them up and figuring out like what equations are you supposed to use. So here's an example. The sum of two positive numbers is 100. What is the smallest possible sum of their squares? So how do we set this up? The sum of two positive numbers is 100. They're positive. I want the smallest possible sum of their squares, so why don't I say s is x squared plus y squared, and I want the smallest possible value of s. So the main problem on these is to find the thing that you're trying to maximize or minimize. In this case, I'm trying to minimize this because it's the smallest possible sum. So I want to minimize this, but you want to take whatever you're trying to maximize or minimize and write it in terms of one variable. Right now it's in terms of two variables, x and y, but you should be given enough information in the problem to get that down to one variable. In particular, I have this equation, and I can use this to say I can solve for y and then put that in for y, and then this will be entirely in terms of x. So that's what I'm going to do. Y is 100 minus x. So s is x squared plus 100 minus x squared. Right? And maybe I could multiply this out and simplify it, but let me not even do that. Now that this is in terms of one variable, now I'm going to basically maximize and minimize it. Well, minimize it, because in this case it's the smallest, but how does this go? You find the critical numbers. The critical numbers would be where the derivative is 0. So let me find s prime. That would be 2x plus, okay, here I have a little chain rule, so 2 times 100 minus x to the 1 times the derivative of the inside, which is negative 1. The critical numbers would be where that's 0 or undefined. Let me just take a moment to point out this is never undefined, this is a polynomial. So it's always defined, but we should still set it equal to 0. So this is 2x plus, multiply this out. So I would have 200 times negative 1, so negative 200, and then a negative 2x times negative 1, so plus 2x. So 4x minus 200. Right, and I'm setting that equal to 0, so I would get the 200 over and divide by 4, I would get x equals 50. Okay. Now, our answer is going to be that, well, our value of x is going to be 50, but we should check that. What we're actually checking is that this value really does minimize s. I want to make one of these number lines with s prime, and in fact, s prime is, we took this and we simplified it. It was 4x minus 200. what I'm checking is that it actually is a minimum that occurs at x equals 50. Maybe I should also mark 0 because I'm not considering anything negative. I'm only considering positive values. So I'm not going to worry about anything to the left of 0. So what I have is I have two intervals from 0 to 50 and 50 forever, 50 to infinity. If I plug in values, say I can plug in x equals 25 here, s prime is 4x minus 200. So if I put in 25 for x, I get negative 100. So this is negative. Meanwhile, if I put in a value of x here, say x equals 100, I'm going to plug this in and I'm going to get 200. So that's positive here. This is indicative of a minimum. It's decreasing, and then we hit this point, and then it's increasing after that. That would mean that this is a low point. It's on its way down, and then it hits this point, and then it's on its way back up. So that would be a low point. So a minimum occurs at x equals 50. And now we just have to make sure that we technically answer the question, because the question was, what is the smallest possible sum of their squares? Well, if x is 50, and remember my two numbers were x and y would also be 50 because they have to add up to 100. And then the question is really about s. What is the sum of their squares? Well, it would be 50 squared plus 50 squared, which is 2,500 plus 2,500, which is 5,000. So the answer is 5,000 on that one. Okay, let's do another one. Find the point on this line that is closest to this point. It's not really necessary, but and I'm not the world's best artist, but let me just illustrate this. So here's the point 1, 3, and then the line y equals 3x minus 2 would be like here. So I want the point on this line that's closest to this point. But this picture isn't really going to help us do it. I just wanted to show you what we were doing. So say I have a point, x comma y, and this question is about the distance from that point to this point. So the question is about this. It's about the distance between a point and this point, 1, 3. In particular, I want the closest distance, so I want to minimize this. So first of all, let me just have a shortcut. If I want to minimize the square root of something, what I can do is just minimize what's underneath the square root. If I make the number underneath the square root as small as possible, that's going to make the square root itself as small as possible. The square root of a bigger number just gets bigger. The square root of a smaller number just gets smaller. So this will make my life a little bit easier. So let me give this a name. Of course, it's just d squared, but maybe let me give it a better name than that. I don't know, f. So once again, this is what we're trying to minimize, but we want this in terms of just one variable. So how do we get this in terms of just one variable? we should have enough information to replace one variable with something else. In our case, we know we're looking at a point on this curve, so y is 3x minus 2. So this is 3x minus 2 minus 3 would be 3x minus 5 squared, like that. Yeah, and then do the derivative. 2 times x minus 1 times 1 is 2 times 3x minus 5 times 3. Let me simplify that. Let's see, I've got a 2x, and this would have an 18x, so 20x, and this would have a minus 2, this would have a minus 30, so minus 32. Yeah. This is never undefined, so we won't worry about that, but we should set it equal to 0. If I'm setting this equal to 0 and solving for x, I would get the 32 over and divide by 20. I can simplify that a little bit, because that's 8/5. Yeah, and then I should do the same thing. Whenever you do this, it's very tempting to just say, okay, I found it. I found my value of x. You want to really check, because we were trying to find a minimum. I want to check this, and what I'm looking for is I'm looking for a number line that's indicative of a minimum. And the last time we did a minimum, and it should be decreasing and then increasing. So basically, what I want to see here, I want to see that it's decreasing and then increasing. And we should just check that it is. So 8/5, this is where it pays to think about decimals. 8/5 is about 1.6. So I'll choose something to the left, how about x equals 0? And I'll choose something to the right, how about x equals 2? And then I'll plug these numbers into the derivative and see whether it's positive or negative. So here's the derivative. If I do f prime, I would just get negative 32, so that's negative. And then if I plug in x equals 2, I get 40 minus 32, which is 8, which is positive. And that's what we were expecting, that's what we were wanting, but we do need to check that. So this does mean that a minimum occurs at x equals 8/5. And in the end, I just want to make sure that I answer the question. The question was to find the point. So at this point, I know the x-coordinate of the point was 8/5. The y-coordinate of the point is just whatever I get from plugging this in. 3 times 8/5 minus 2 is, let's see, this is 24/5 minus 10/5, so 14/5. So that's the point that's closest to 1, 3 on this line. Okay. So there's several problems about farmers wanting to enclose a rectangular area. In this case, I have a rectangular area, but I want to put these walls to divide this into 4 pens, so there's like 4 smaller rectangles. I have 750 feet of fencing, and I want to know what's the largest possible area. So if I call this y, and I call this x, I want to talk about the area. I want the largest possible area, so I want to maximize the area. The area would just be x times y. But as usual, I took the thing that I want to maximize or minimize, and I see that it's in terms of two variables. I want just one variable. So I need to find some information that allows me to replace x or y. What I know is something about the total amount of fencing. There's 750 feet of fencing. So that's going to help me. So the amount of fencing, let's see, I've got one side of length x. I've got another side of length x. So that's 2x. And then I've got 1, 2, 3, 4, 5 pieces whose length is y. And that would equal 750 if I use all the fencing. Okay, so this is going to allow me to solve for x or y. I get to choose which one. Let me solve it for x, I guess. So I would subtract this over and divide by 2. X equals 375 minus 5 halves y. And then I'll put that in. Whoops, I'm replacing x. So I get this. And I'm about to do the derivative, so I would prefer to just multiply this out. 375 minus, or 375y minus 5 halves y squared. So now I'm going to do the derivative, and I'm doing the derivative with respect to y. Now, y is my variable. So, you know, this isn't like implicit differentiation. When I do the derivative of y, it's just 1, because I'm doing the derivative with respect to y. So 375 minus 5y, because the derivative of this would be 2y, and then the 2's cancel, right? So here's a prime. As usual, this is never undefined. We need to check that, though. The critical numbers include anywhere where it's undefined, but most of the time we find that that's not an issue. What I should do now is set this equal to 0. So if I set this equal to 0, that's going to mean 5y equals 375. So y is, oh boy, can I do this in my head? 5 times 75 would be 350 plus 25. Yeah. Okay. So then I have to do a little bit of checking. I want to draw a number line, and I want to see that this is indicative of a maximum, because in this case I want the largest possible area. And this is something that I expect this to work out, but I need to check it. I need this to be indicative of a maximum. In other words, I want this to be increasing, so A prime should be positive here and it should be negative here. I fully expect this to work out, but I need to check. Over here, I can try my favorite number, 0. A prime would be 375 minus 0, so that's positive. Good, that's what I was expecting. Over here, I can do y equals, say, 100. I plug that in, I get 375 minus 500. I get a negative number. That's good, that's what I was expecting. So this checks out, there is indeed a maximum that occurs at y equals 75. Now we want to make sure I actually answer the question. The question is, what is the largest possible area? So I should find out what's the area when y is 75. Maybe I'll use this formula. So this is 375 minus 5 halves of 75 times 75. And I am officially going to need a little bit of help with this. I don't trust myself to do it in my head here, but this will take just a second. Come on. Okay. 375 minus 5 halves times 75. All of that times 75. Sorry, this is taking too long. Yeah, so I get 28125 over 2, which maybe it would be nice to have that as a decimal, right? This is 14062.5. And yeah, let me just emphasize something. And of course, this is square feet because distance was measured in feet. So there's been a lot of issues in the online homework about exact answers and decimals. So I'm okay with this decimal because this is exactly 0.5. Like I didn't round anything off. Like this is just, the denominator is 2, and if we have an odd number on top, so like it's exactly like a 0.5 at the end. I'm not cutting off anything. I'm not rounding anything. This number is exactly this number. So I don't have a problem with this, and the online homework also would not have a problem with this. The problem is when you do something like, if the answer is pi, and then what you put in is, 3.14, that's not exactly right. Because pi is not exactly 3.14. There's more decimals that you're just cutting off. Even if you included some more, like 3.14159, there's still more. Pi goes on forever, and you're cutting something off. That's when you are going to run into an issue with the online homework. So we need to know the difference between answers that are exact and answers that are not exact. Up here, this decimal is fine because this is exactly true. I'm not cutting off anything. It's 0.5000000 forever. So let me cross this off because pi is not exactly equal to that. Okay. Let's do one more example. We want to make a box with a square base, no top, and only 3 sides. So one of the sides is missing. So I've drawn, I didn't do it, again, I'm not the world's best artist, so I drew a box here. It has a square base, so this is x and this is x. It's the same length. That's a square base. But the height is not necessarily x. Like this isn't a cube necessarily, so the height could be different, but the base is a square. There's no top, and one of the sides is missing, so there's like no material here. Okay, so I want to make a box like that. The top missing and one side missing. We have a total of 3 square feet of material. And the question is, what is the largest possible volume? Okay. Well, this is a question about volume. The volume of a box is length times width times height, so it would be x squared y. As usual, here I have the thing that I'm trying to maximize in this case, because it's the largest, but I would like it in terms of just one variable. So I have to find some information that would allow me to solve for either x or y. What I know is the total amount of material that I have. So I'm going to take 3. And how much material would this use? So a box, typically a box has 6 sides, right? But we're missing some. So let me just count these. I've got the bottom, which would be x squared. I would have the top. The top would be another x squared, but I don't have the top. The top is missing. Other than that, I have the sides. So that I would have the front, which is x times y. I would have the left side, which is x times y. I would have the back, which is x times y. I do not have the one on the right. So if you count that up, I've got 3 sides that are x times y. And that's it. That's all the material. Okay? So I'm going to take this and I'm going to solve for one of the variables. This looks a lot easier if I solve it for y instead of x. And it's my choice, so I'm going to solve it for y. So y would be, if I divide everything by 3x, I would get 1 over x minus x over 3, right? X squared over 3x would be x over 3. Right. So I'm going to plug that in. So v is x squared times this. Let me simplify. So it's x minus 1/3 x cubed. Let's do the derivative. 1 minus x squared. It's never undefined. Set it equal to 0. So this would be x squared equals 1, so x is plus or minus 1. Now in this we want to use some common sense. X is the dimension of a box, so -1 doesn't make sense. It doesn't make sense for a box to have a side of length -1. So let's just take the positive one. I want to make one of these number lines. Since we just realized that x is positive, so I'm not going to consider anything to the left of 0. So I'm going to mark 0. I'm not going to consider anything over there. I'm also going to mark 1 because that was our critical number. So then what I would like to see, since I'm going for a maximum here, what I would like to see is that this is increasing and then decreasing. And we can see that. If you plug in x equals 1/2 and get phi prime, this would be 1 minus 1/4, which would be a positive number. If you try x equals 2, you'll get 1 minus 4, which is a negative number. So there is a maximum that occurs here. And then let's just make sure we answer the question. The question is, what is the largest possible volume? The volume when x equals 1, the volume is 1 minus 1/3, which is 2/3. And everything was measured in feet, so this should be cubic feet.